Systematic reasoning supports scientific thinking by providing a clear, step-by-step way to observe, form a hypothesis, test that idea, and revise conclusions based on evidence, which mirrors how scientists solve real problems. Think of systematic reasoning like following a recipe when you bake a cake. But for science, you first notice something interesting, like plants growing faster near a window, and you ask a question about why that happens. Then you guess a possible answer called a hypothesis, for example, that more light makes plants grow faster. And you design an experiment that changes only the amount of light while keeping everything else the same. You collect measurements, write down what happened, and look at the data to see if it matches your guess. If it does not, you change the hypothesis or try a new experiment until the evidence makes sense. This careful order, observe, question, hypothesize, test, and revise helps scientists avoid jumping to the wrong answer and builds reliable knowledge that others can check and repeat. A common mistake is changing too many things at once in an experiment, which makes it impossible to tell which change caused the result. So always change only one condition and keep the rest constant. Another mistake is trusting a single experiment as proof. One test can give a hint, but repeatable results are needed. So run trials and compare outcomes to be confident. Students also sometimes ignore how important careful measurement and clear records are, and that leads to messy data. So write down procedures and numbers carefully so someone else could repeat the work. For more videos and resources that explain how systematic reasoning works in chemistry and how scientists approach real problems, check out www.gumballdegree.com.